In this video, let us solve some problems based on trigonometric ratios. So here we have the problem, which reads like this. ABC is a right-angled triangle, right angled at C. If A equals 30 degrees and AB equals 40 units, find the remaining two sides and angle B of triangle ABC. Now, if you can think a little bit, this is kind of another way of solving trigonometric problems. Before, we used to have, say, a minimum of two sides given in a right angle triangle, and we'd be asked to find the trigonometric ratios. But then here, we are just given one angle, and then we're given one side, and we have to find the remaining two sides and an angle B of triangle ABC, which is not a big deal. It's still simple stuff. I'm just telling you the difference between what we've done up till now and how this is different from those. So first of all, let's have the right angle triangle constructed. So since I've clearly mentioned it is right angle at C, let's name this C and say let's name this AB, and this is going to be 40 units. And angle A is going to be 30 degrees. So this is 30 degrees. So now we got to find this angle, right? And then the remaining two sides. Now finding this angle is very simple because we've got 90 and a 30. So this angle should definitely be 60 because 90 plus 30 is 120. And what if you add to 120 gives you 180? It's 60 degrees. So this is a very elementary thing. So let's not worry about this too much. Let's concentrate on how do we find the remaining two sides. So we've got 40 of this. We need to find these two. So how do we go about that? Now we've got the hypotenuse. We can either start off with A or with B. That's no problem. Say, I'll start off with angle B. So say, for example, we take sine of 60 degrees. We know the value of sine 60. So sine 60 is nothing but opposite by hypotenuse. So the opposite is AC. So if we use sine 60, we will find AC because we know sine 60. Okay, let me write it here. Say, for example, sine 60 degrees, it will be opposite to sine 60 is AC. So AC divided by the hypotenuse. Hypotenuse is 40. So we know sine 60, we know 40. So we can easily find AC either by this method, or I can find AC from this side by using cos 30 degrees, because cos 30 degrees is nothing but adjacent by hypotenuse. Adjacent to 30 degrees is AC again. So AC by 40. Or we can do sine 30 degrees and find out BC by the hypotenuse, which is 40, because the opposite of 30 is BC. Cos 60 degrees equals BC by 40. So these are the two options by which you can find both the sides. You either use this one, or say use sine 60 and cos 60, or use cos 30 and sine 30. Any way that you want. So what I'm going to do is I'm going to use this method here. So sine 60 is root 3 by 2. Root 3 by 2 equals AC divided by 40. So now AC equals 40 root 3 by 2. So 2 goes 20 times in 40. So we have AC equals 20 root 3 units. So this is AC for you. Now let us find BC. Let's find BC now. Say sine 30. So now I'll just mark it here so that you don't get confused. Now I'll use the sine 30 is nothing but 1 by 2. 1 by 2 equals BC by 40. So BC equals 40 by 2. 2 goes 20 times in 40. So BC equals 20 units. So here they are. AC is nothing but 20 root 3 units and BC is nothing but 20 units. So now what we've done is we've used sine for both of them. Now quickly let's use cos. And why don't we recheck it now? And just split this up and let's use cos now. So cos 30 degrees is nothing but root 3 by 2. Root 3 by 2 equals AC by 40. Again we have AC equals 40 root 3 by 2. So 2 goes 20 times. So we have AC equals 20 root 3 units. So AC is verified. So here also we've got 20 root 3 and we've got 20 root 3 even here. So now let's use cos 60 degrees equals BC by 40. So cos 60 is 1 by 2. So 1 by 2 equals BC by 40. BC equals 40 by 2, which is nothing but 20. So BC equals 20 units. So that is also verified. So this is the way we can solve these problems. Very simple problem. It's very conceptual. I mean, you use the basics of trigonometry and find the values or find the answers for the given questions. Nothing much confusing or complicating in this. I hope you understood. Let's solve another problem. So here we have another question which reads like this. In a rectangle ABCD, AB equals 20 centimeters, angle BAC equals 60 degrees. Calculate the side BC. So here we have the rectangle ABCD. It says that angle BAC equals 60 degrees. So angle BAC, so we got to draw a diagonal. So this is going to be 60 degrees. Angle BAC is going to be 60 degrees. AB is going to be 20 centimeters. We need to calculate the side BC. So again, it is nothing but a right angle triangle, just given in the form of rectangle. So nothing much different from the previous problem. So what we have to do in this problem is, in triangle ABC, we have AB equals 20 centimeters and angle BAC equals 60 degrees. Since we need the side BC and we already have AB, so it is going to be, the two sides are going to be opposite and adjacent, or adjacent and opposite. So which of the trigonometric functions involves the sides adjacent and opposite? The first thing that comes to my mind is tan. So tangent of angle BAC will be equal to opposite by adjacent. So tangent of 60 degrees will be equal to, opposite is what we have to find, which is BC, adjacent is AB. So tan 60 degrees is root 3. We need to find BC. AB is 20. So BC equals 20 root 3 centimeters. So that's all. This was another very simple problem. I hope you understood this. I'll just summarize this problem for you once more. Now the question is, in a given rectangle ABCD, AB is 20 centimeters given and angle BAC is equals 60 degrees. We need to calculate the side BC. Now the data that we have is one angle and one side. Okay, but we need to find BC. So BC is nothing but, it is an opposite and this is an adjacent. Opposite and adjacent, we need to use tan function because we know adjacent and we know the angle. So tan of 60 is going to be root 3. All we have to do is find BC. So this is the way to find BC. This ends this video. The forthcoming videos, let us solve more advanced problems based on trigonometric ratios.